All right, welcome back to Workplace and Apprenticeship 30. We are continuing with section 2.1, which is titled Accuracy and Precision. If you look at example 2 on page 84, we have a Canadian that won the downhill alpine ski race with a time of 1 minute 27 seconds, 0.51, and the second place finisher was 0.66 seconds behind her. So what was the precision that the timer used, and what was the uncertainty? Remember that precision is the smallest unit that could be used, and the uncertainty is half of that. So what is the smallest unit that was used here? Milliseconds, so 0.01 seconds would be your smallest unit. Now your uncertainty is half of that, and remember it's always plus or minus because it's how you rounded that number. So what would be the uncertainty? No, 0.005 seconds would be your uncertainty. So now let's write the first place finisher's time, including the measurement uncertainty. So the first place finisher was 1 minute 27.51 seconds plus or minus 0.005 seconds. Part C, what was the time of the second place finisher, including the measurement uncertainty? Given the uncertainty, write the maximum and minimum times it could have taken her to finish the race. Okay, so remember that if we are doing two different calculations, we have to include two different uncertainty amounts. So if we have 1 minute 27.51 was the first place finisher, and this person was 0.66 seconds more than that because she finished with a slower time. Then we add those two numbers together to get a total time of 1 minute 28.17 seconds. So that would be your total time. But each of these two numbers that we came up with already have an uncertainty attached to them. So we have to add those uncertainties together. So our total uncertainty becomes 0.01 seconds. So now our answer would actually be 1 minute 28.17 seconds plus or minus 0.01 seconds. So if we look at the maximum time it would have taken her, we'd add 0.01 seconds onto this number, so the max would be 1 minute 28 seconds 0.18, and the minimum time it would have taken her would be 1 minute 28.16 seconds because it's off by 0.1 in either direction. So for example 3 on page 84, we're going to calculate the precision and uncertainty for each of these questions. So A, she has a fridge that is 71 plus or minus 0.5 centimeters wide, and a stove which is 76 plus or minus 0.5 centimeters wide. She wants to calculate their combined width. So what do I have to add together first? Their widths. Yep, so 71 plus 76 equals a total of 147 centimeters is their total width. Then we also have to add together their uncertainties. So 0.5 centimeters plus 0.5 centimeters equals plus or minus 1 centimeter. So if I want to write that out then as my final answer, I would write 147 plus or minus 1 centimeter would be the length, the width of these two combined. If you look at B, you want to calculate the total shipping weight of these three packages with these individual weights. So first I need to add together all of these weights. So I'll go 16.5 plus 2.8 plus 1.4. So my total weight is 20.7 kilograms. Is that what everybody got? Okay, good. Then we need to add up the uncertainties for all of these. So if you look at these three numbers, what would be the precision for each number? The precision. So 0.1 kilograms, because they each have one decimal place. So if the precision is 0.1, the uncertainty is half of that. So 0.05 would be the uncertainty for each one. So we add up all these uncertainties because each measurement would have its own uncertainty. Add them all up to get 0.15 kilograms would be plus or minus for your uncertainty. Then your final answer would be 20.7 plus or minus 0.15 kilograms. Final answer. Right, try the last one on your own. The key with this last one though is to make sure both of these are in the same units. So I would change centimeters to meters and then add them from there. If you check your answer on the board, it should be 1.99 plus or minus 0.01 meters. Now notice that you always add the uncertainties. It doesn't matter if you're subtracting in the part before, you always add the uncertainties. So discuss the ideas. We've got a dog sled race, which is approximately 600K. This is just from the first leg. So team number 1 did the first leg in 5 hours and 23 minutes. We want to figure out the precision of the time measurement and what is the measurement uncertainty. So what is the smallest unit here that is being measured? Okay, would hours be your smallest unit? No, your minutes would be your smallest unit. So your precision is 1 minute. So then your uncertainty would be what? Half a minute, or how else could I write that? Or 30 seconds. Now we always want to keep the same unit, so here we would stick with minutes, just showing you that that is an option. So question 2, record the max and min times it could have taken each sled dog team to finish the leg. So we have to account for this uncertainty. So example, team number 1, the clock says that it took them 5 hours 23 minutes, but it could be 30 seconds more than that, or it could be 30 seconds less. So what would my max time be then for team 1? No, these are not 5:53 because these are actually minutes. 5 minutes, 23 seconds, sorry, 5 hours, 23 seconds, 0.5, because you're adding on that half a minute. Then the minimum time would be 5 hours, 22 minutes, 0.5, because that would be half a minute less than your 5:23 that was recorded. Okay, so go ahead and finish the rest of that chart. All right, once you've got those all recorded, you can have a look at how much time separated the first and second place finishers. So first place is the 5:11, second place is the 5:17. So 6 minutes separates first and second, but if you take your minimum time for your first place finisher, which would be 5 hours, 10 minutes, 0.5, and the max time for your second place finisher, which would be 5:17.5, you would end up having less than that. You'd end up having 5 minutes between. So it depends on your uncertainty on how much, on how the rounding actually went. Okay, sorry, I made a mistake on that one. If you look here, it should have actually been your minimum time for the second place finisher and your maximum time for the first place finisher to get a separation of only 5 minutes. So then if you look at part 3, would it be useful to actually record the time more precisely by recording the seconds as well? So would it have made a difference in the race if you would have recorded seconds? So I'm getting some yeses, some no's. Would it have changed the outcome of the race? No. Good, so none of these times are close enough, so it wouldn't have actually needed seconds to change the outcome. So why then in, say, a 100-meter sprint, would they record hundredths of seconds? Good, because it is closer, so you do need that much more accuracy. So here, race organizers might not have decided to use the seconds because it just, it takes more precision and it takes more effort to actually go to those precise digits, whereas if they know it's not going to be that close, they could leave it like this. Okay, now different tools also have different amounts of precision, accuracy, and uncertainty. So a ruler would be good for short linear dimensions, but not diameters or round objects. A tape measure is good for longer linear dimensions, but again, not diameters or round objects. Then you have a caliper, which can measure inside or outside diameters or the depth, and a micrometer, which has more precision than a caliper, but it can only do one measurement at a time. So a caliper could do both the inside and the outside, but the micrometer could only do one at a time. Then try the mental math. Go ahead. All right, pause the screen here and just double check your answer on the board. And then you can move on to your homework assignment, which is page 88, 89, number 8 to 5.